Okay, so now we want to look at solid shapes. In the first sections of mensuration, we were looking at plane shapes, flat shapes that don't project from the ground. Now we're looking at solid shapes that rise from the ground. Now for solid shapes, we have two main things we want to look at. The first thing is going to be volume. And then we'll talk about surface area. Well, there is a third thing. We'll talk about density. So when it comes to solid shapes, the three things we want to know are the volume, the surface area, and the density of the shape. So the first thing we're going to talk about is the volume. So volume is the amount of space taken up by a solid shape. So how much space is taken up by a solid shape, we call that the volume. Okay, how much space is something taking up? That's the volume. Now volume has got a variety of units. The common units are cubic centimeters, milliliters, liters, and cubic meters. So these are the common ones we can expect to use in our syllabus: cubic centimeters, milliliters, liters, and cubic meters. And one or two conversions that may be useful. 1 liter, or let me start with this: 1 cubic centimeter is actually equal to 1 milliliter, and then 1 liter is equal to 1000 cubic centimeters. 1 cubic meter is equal to 1 million cubic centimeters. So these are some conversions which I have seen necessary in many papers that I've looked at over the years. So now let's proceed. Now, if you are going to calculate volume, you need to understand a group of shapes known as prisms. So there is a group of solid shape known as prisms. So what is a prism? A prism is a solid shape with a uniform cross section. So a prism is a solid shape with a uniform cross section, right? So if you look at one end of a prism, the shape you see, that's what we call the cross section. So if we had a shape like this, right, with a block like this, a rectangular block, this shape you're seeing here, that is what we call the cross section, right? When we're saying the cross section is uniform, we're saying we have this square at one end, right? If you go through the prism, you're going to get the same square showing up on the other end of the block, right? So the square that shows up in front is the same as the square that shows up at the back. So the cross section is uniform. It never changes, right? If it's a square here, you have the same square extending right through the block and showing up on the other end of that block. If you have such a shape, that shape is a prism. A shape with a triangle here extends to the other end, you get a triangle. A circle extends to the other end, you get the same circle with no changes in between. That is a prism. Now we have one standard formula for finding volume of a prism, right? Volume for any prism, right, is given by this formula. Volume is equal to area of cross section times height of the prism, right? So it's area of the cross section times height of the prism. If we use our block, that block that I showed you earlier on, right, this will be our cross section, and then the block extends from one end to the other. Didn't draw it as well as I did the first time. The distance from one end where there's a cross section to the other end where there's the other cross section, right? That's what we call the height of the prism. So I know you expect height to be projecting upwards always. It's not always the case, right? Height can go up or it can go sideways. It's like a person. When you're standing, you measure your height going upwards. But if you lie down on the ground, what do? We measure your height going along with your body from your feet to your head. So the feet and the head of a prism are the sides with the cross section. So the height is always measured from an end where the cross section is being taken to the other end where the cross section is being taken. So let's look at different shapes and let's see how this translates. So first of all, let's look at a rectangular prism or a cuboid rectangular prism. We call it a rectangular prism to make it clear. So let's say we've got something like this. We've got a shape like this. This time, just going to be friendly and put my height going vertical. So here's a block here. It's got this side with length, that side with width, and we can take that to be cross section. And then this is the height going from this side is the height. So what do we know? Volume of any prism is area of cross section. The cross section is a rectangle. We know that a rectangle, area of a rectangle is length times width. So we say area of cross section, length times width, then times height. You see, we are following this formula. Area of cross section was length times width, and then we multiplied by height of the prism. So it's length times width times height. That's how you calculate volume of a rectangular prism. Now let's go to the next shape, which is a cylinder. A cylinder is a circle on one end. It extends and you get a circle on the other end on the base. Then a green just to show the internal parts of that shape. So what we know is that for every circle, there is a radius, right? There's a radius r. R is the radius of the circle, and this h is the height. So it's the distance from there to there. So that's the height. Now, how do we find volume? Volume of a prism is area of cross section. What's our cross section this time? This time, our cross section is a circle. And area of a circle is pi times radius squared. And then once you've got your area of cross section, you multiply the area of cross section times the height. So again, we're following that formula. Volume of a prism is area of cross section times height. In this case, our cross section was a circle, so it was area of circle then times height. Let's try something else. Let's try a triangular prism. Let's try a triangular prism. A triangular prism, I have a triangle on one end, and this time the shape is lying flat on the ground. Let's say that's the height of the triangle, and let's say that's the base, and this is what we're taking as our cross section. The end from the cross section to the other cross section, that's our height there. Now, volume of a prism is area of cross section times height of prism. So what's our cross section? Our cross section is a triangle. Area of a triangle is half base times height. So this is area of cross section. Then we multiply by height of prism. So don't confuse the height of the triangle with the height of the prism. Again, we're obeying our law or our formula. Volume of a prism is area of cross section times height. The next thing we are going to look at is a trapezoid. So this time we have a trapezium as the cross section of a prism. So here's our trapezium. Then our prism is going to extend like that. And then the parallel sides of your trapezium going to be A and B. And then the trapezium is going to have its own perpendicular height h, and then from cross section to cross section we'll have the height of the prism, which I'll represent with capital letter H. Now, how would you find volume of the prism? Volume of a prism is area of cross section times height of the prism. What is the area of the cross section? The cross section is a trapezium. Area of a trapezium is half of a plus b times height of the trapezium, and then I multiply the area of cross section times height of the prism. So that's how I get the volume of that trapezoid. It's the same formula, so it doesn't matter what the cross section looks like. Just find the area of the cross section and multiply by height. So now let's look at shapes that are not prisms. Okay, so for shapes that are not prisms, we need to know their formulas. So the first one is a cone. So a cone is a point at one end and a circle. It is a circle, so this is going to go in there like a circle. Then we're going to have a height, then a radius. So for any cone, the formula for the volume is going to be 1/3 pi r squared times height. 1/3 pi r squared times height. So in this case, it's 1/3 base area times height. So if you look at these pointed shapes, these shapes that rise to a point, the basic formula for them is 1/3 base area times height. So the base was a circle, so area of a circle is pi r squared. So we're going to look at another thing, which is a pyramid. So if you have a pyramid, it's going to have a length and a width there, right? If it's a rectangular base pyramid. And it's going to have the height. I'm going to show the height with this h here. Volume of a pyramid is going to be 1/3 the base area, right? 1/3 length times width, then times the height. So that's what happens. When you're finding volume of a pyramid, you say 1/3 base area times height, which is just the same with a cone, 1/3 base area times height. You look at what kind of shape the area at the base is. Okay, so the last shape we're going to look at is a sphere. So for a sphere, it's a ball-like shape, right? A sphere is a ball. But we know somewhere within that ball there is a radius. The volume of a sphere is 4/3 pi times radius cubed. So it's 4/3 pi times radius cubed. And that's going to give us the volume of the sphere. So we'll try some of these questions and we'll see what happens.